center of the circle to any one point on the edge of the circle, then we have a radius. You are now seeing on the screen multiple radii that can exist within one circle. I would also like to point out the fact that the radius and the diameter of a circle are different. Both of these line segments will pass through the center of a circle. However, the radius will touch only one point on the edge of the circle, whereas the diameter will touch 2 points on the edge of a circle. We are now going to look at the definition of a chord. A chord is a line segment that connects any 2 points on the edge of a circle. In the diagram that you are seeing now, we have a chord. Furthermore, other examples of chords are Let's now introduce the definition of an arc. Now that you know what a chord is, you will be able to appreciate what an arc is. An arc is the edge of a circle that runs between the endpoints of a chord. Also, we can say that the arc of a circle is any connected point running along the edge of the circle. If we consider a chord in the diagram, the arc will be the edge of the circle that is connected by the endpoints of that chord. You can see this in the diagram. Now, let's look at the definitions of the sector and the segment of a circle. What is a segment? A segment is the area within a circle that is created by a chord and its arc. In the diagram that you see now, the shaded region represents a segment of a circle. Let's now look at what a sector of a circle is. A sector is the area within the circle that is created by 2 radii and the corresponding arc that is formed by those radii. So, let's draw in a radius. Now we will draw in another radius. You will now see that there is an arc that is formed between the 2 points at which the radii touch the edge of the circle. This then forms an area within the circle. We call this area a sector. If it makes it easier for you to understand, you can think of a sector as a slice of pizza. We will now look at the final definition of a term that is used in circle geometry. This is probably the most important of all terms relating to circles. It is the circumference of a circle. What is the circumference of a circle? The circumference of a circle is the perimeter of a circle. In other words, the circumference of a circle is the outer edge of the circle.
In this lesson, we will discuss the formula for the area of a circle. We will look at 2 examples, and to end off, we shall recap everything we have just learned.
How to derive the formula for the area of a circle. Imagine a circle with center O. This circle has many lines from the center to the circumference, called radii, as well as many straight lines called diameters, which are made up of 2 radii. If we want to calculate the area of the circle, maybe breaking it down into smaller shapes would help us. Archimedes thought this as well and discovered the formula we use today. Let us investigate further. Draw in 2 diameters. This breaks our circle into 4 parts. We can unravel the circle into the following shape. If we flip 2 of them onto the other 2, we end up with this shape. We can see that the 2 curved parts at the bottom are half of the total circumference. Therefore, since the total circumference is 2 pi r, half the circumference would be half of 2 pi r, which would just be pi r. In addition, we see that the height of the shape is r, since it is the distance from the center to the circumference. The more diameters we draw in, the more the shape starts to look like a parallelogram. And finally, the shape becomes a rectangle. Therefore, using the formula for the area of a rectangle, which is length times breadth, we can determine the area of a circle. The length will equal pi r, and the breadth will equal r. Therefore, the area of a circle is pi r times r, which equals pi r squared. Thank you, Archimedes.
Let us discuss the formula for the area of a circle. So if we have a circle and we know the radius, the area of the circle is given by pi r squared. So r is the radius, and pi is a constant that is a non-terminating, non-recurring decimal. So we leave all our areas in terms of pi. Let us look at an example. So what is the area of a circle that has a radius of 5 centimeters? So here's our circle. It has a radius of 5 centimeters. The area of a circle is given by the formula pi r squared. So the area is equal to pi times 5 squared, which is equal to 25 pi centimeters squared. Always remember, area is measured in square units. So if we start off in centimeters, our area will be in centimeters squared. If we were to start off in meters, our area would be in meters squared. Let us look at another example. So what is the area of a circle that has a diameter of 12 centimeters? We know the area of the circle is given by pi r squared. So first thing we need to do is convert our diameter to a radius. So if we draw our circle, we know its diameter is 12 centimeters, but we also know the diameter is equal to twice the radius. So if our diameter is 12, this tells us that our radius is equal to 6 centimeters. So this means the area of our circle is equal to pi times 6 squared, which is equal to 36 pi centimeters squared. Remember, area is in square units. Let us recap everything we have just learned. So the area of a circle is given by pi r squared, where r is the radius and pi is a non-recurring, non-terminating decimal. So we leave all our areas in terms of pi. So pi is an irrational number, it's non-terminating and non-recurring, hence it's best to leave your answer in terms of pi. If we were to write pi as a number, it would be equal to 3,141,592,6535, and it goes on and on. These are just the first 10 decimal places. Another thing to remember is that the area is measured in square units. So if your measurements are in centimeters, your area will be in centimeters squared. If it's in millimeters, it'll be in millimeters squared. If it's in meters, it'll be in meters squared. In this lesson, we will look at the components of a circle. We will then discuss the formula for the perimeter of a circle. We will look at 2 examples. And to end off, we shall recap everything we have just learnt. Let us discuss the components of a circle. So we have the following ones. We have the center, the radius, the diameter, the circumference, a sector, a chord, and an arc. The center is the middle of the circle. It's where you would put your compass if you were drawing the circle. The radius is the distance from the center of the circle to any outer edge of the circle. So this is a radius. Could also have this is a radius. Could also have this is a radius. Or this. Point is, they're all equal in length and they're drawn from the center to any point on the outer edge of the circle. Next up, we have a diameter. This is a line that passes from one end of the circle to the other, but passes through the center of the circle. So this here is a diameter. Usually we think of diameters as the distance from one end to the other passing through the center. This would be another diameter. Could also have this is a diameter. They're all equal in length. They all pass through the center and they go from one side of the circle to the other. The circumference of a circle is the length you travel around the circle. So, imagine cutting a circle and unraveling it. That distance that it unravels to would be the circumference. A sector of the circle is the area enclosed by any 2 radii. So imagine you have 2 radii. That's the area enclosed by them and the outer edge of the circle. Another example of a sector would be this. Could even be really big, so this. One way I like to think of a sector is imagine your circle as a pizza. A sector would be a single slice. A chord is a line drawn from one side of the circle to the other. It does not have to pass through the center. Although, if it did, it's still a chord, because it travels from one side of the circle in a straight line to the other. So here's some examples of chords. We can have big ones, we can have really small ones, but it must go from one side of the circle in a straight line to the other. So going back to this chord, it goes from one side of the circle to the other, and it passes through the center. So this is a diameter, but it's also a chord. So you can think of the diameter as a special kind of chord. And lastly, we have an arc. So an arc is any section of the outer circle. So let's say between here and here, we have this as our arc. So let's say we decided to partition our circle into two arcs. This would be our minor arc, and all the way around the circle would be our major arc. We don't even need a circle to have an arc. As long as we have any section of a circle, so imagine that, this would still be classified as an arc.